Welcome to the Explainer. So, you've probably used tools like ChatGPT, right? But if you ever wondered how they actually work, well, today we're going to peek under the hood. We're building a large language model from scratch, piece by piece.
You know, it can feel like pure magic, but it's not. It's actually this really brilliant process of engineering. So let's start this journey, this builder's journey, and really demystify how a machine can learn to write just like a human.
Okay, so here's our game plan. We'll kick things off with the basics. What even is an LLM? Then we're going to roll up our sleeves and teach a machine how to read. From there, we'll dive deep into the core, the real secret sauce, which is self-attention. After that, we'll see how you assemble all these pieces into a full model, how you train it, and maybe most importantly, why any of this stuff even matters.
All right, first things first, what is a large language model? I mean, what are we really talking about here? At its heart, it's a deep learning model that's been trained on just an insane amount of text data. All that training is what lets it understand and generate language that sounds, well, human.
And you know, the real game changer here is that unlike the old days of AI, we don't have to sit there and hand code all the rules of grammar. It's kind of wild. Just by learning from these enormous text data sets, the models start picking up skills we never explicitly taught them. Things like summarizing an article, or heck, even writing a poem. This is that powerful idea people call emergent behavior. Okay, so a computer can't read the word journey the way you and I do. It just sees, well, nothing it understands. So the very first problem we have to solve is how to translate our language into numbers, a format a machine can actually work with. Let's break down how it's done.
This whole translation thing, it happens in 4 key steps. First up, tokenization. This is where we just break the text into smaller, manageable chunks. Think of them as words, or even parts of words. Then, each of those chunks, those tokens, gets its own unique number, an ID, kind of like an entry in a massive dictionary. Step 3, we create embeddings. Now this is cool. These are rich, numerical vectors that actually capture the meaning of each token. And finally, and this is absolutely crucial, we add positional info. Why? Because the model has to know that dog bites man is a very different story from man bites dog.
Okay, so our words are now numbers. Great. But how does the model figure out context? How does it know what words mean together? Well, this is where the magic really happens. The secret ingredient, the absolute genius of this whole system, is a mechanism called self-attention.
The best way to think about it is like a spotlight. For every single word it's looking at, the model shines this spotlight back on all the other words in the sentence. It's trying to figure out, okay, which of you guys are most relevant to understanding this word right here?
So let's get into the weeds just a little bit. For any given word, the model generates something called a query. You can literally think of this as the word asking a question out loud to the other words. Hey, who here is most relevant to me?
And in response to that question, every other word in the sentence holds up a sign, a key, that basically says, this is who I am and what I'm about. The query then looks at all these keys and calculates a score. Who's the best match? Who's most relevant?
Right, so once it has those relevance scores, the model pulls a value from each word. The value is like the actual substance, the meaning. It then creates a brand new, super context-rich meaning for that original word by mixing together all the other values. And of course, it pays way more attention to the ones that had the strongest key query match. This right here, this is the core mechanism that lets the model truly understand context.
But there's one really important rule here. When it's trying to predict the next word, the model is forbidden from cheating. It can only look at the words that came before it. This is called a causal attention mask, and it's the exact reason why it looks like ChatGPT is thinking and typing out its response one word at a time. It's because it is. It's literally predicting the future one single token at a time.
So, that self-attention mechanism we just talked about, that's the heart of a bigger building block called a transformer block. And a really powerful model like GPT, well, it's basically built by stacking these blocks on top of each other, just like building a skyscraper.
Each of these blocks contains a few key parts. Multi-head attention. Think of that as having a bunch of spotlights running at the same time, so the model can look for different kinds of relationships all at once. Then you've got a feed-forward network that does some heavy-duty number crunching to process everything the attention layers found. And finally, you have layer normalization and shortcut connections. Now these might sound technical, but they're just really clever engineering tricks that make sure everything trains smoothly without falling apart, especially when the network gets really, really deep.
So get this, when we stack just 12 of these transformer blocks together, we get the basic architecture for a model, like the small version of GPT-2. And that alone results in over 124 million trainable parameters. Just try to picture that. Each one of those is like a tiny little knob that the model is going to learn to tune perfectly during the training process.
Okay, so we've built our skyscraper, we have the architecture, but an untrained model, it's just pure potential. It doesn't know anything yet. To turn it into a powerhouse, it needs to be trained, and that training happens in two main phases.
The whole process kicks off with pre-training. This is where the model gets its general education. Its only job is to do one simple thing over and over and over: predict the next word. But it does this on a dataset that is basically a huge chunk of the internet. It's like cramming for a final exam by reading the entire library. Then, once it's got that broad knowledge, we move to fine-tuning. This is where we take that super smart base model and specialize it for a specific job, like classifying spam emails or writing Python code.
So there you have it. We've gone all the way from a single word to a stack of blocks to this massive trained model. But why does understanding all this matter? Why is this process so important? Okay, let's just quickly recap the big ideas here. First, language is data. At the end of the day, LLMs work by turning our words into numbers. Second, context is king, and the key to understanding it is that brilliant self-attention mechanism. Third, architecture is repetition. These incredibly complex models are built by stacking simpler, repeating blocks. And finally, learning is a process. Models get their general smarts through pre-training before they specialize through fine-tuning. If you get these four concepts, you've really grasped the fundamental principles behind the AI tools that are, let's be honest, rapidly changing our world.
So, we've basically taken apart the engine and seen how it works. We've demystified the how, but that leaves us with the bigger question. A question for all of us, really, which is, now what? What do we choose to build with this? Where do we drive it? Thanks for joining me on this explainer.